All right, welcome to Unit 1, Lesson 2. We're going to jump right into it with some of these exercises with putting values into functions. All right? So 1a here tells me, okay, this tells me the function I'm going to use, the f function that's here. This tells me what value I'm inputting for x. So what I like to do is I take this function. If f of x equals 4x plus 7, then f of negative 2 tells me I'm going to put a negative 2 in for every x in my equation. What I like to do, and what I highly suggest, is anytime you see an x, you put parentheses there. Okay? So you see how I had an x here? I'm just going to put parentheses here. And I'm going to input my negative 2 right in for it. We have negative 8 plus 7, negative 1. Done. If you want to start doing some of these, I would pause this video now, go ahead and do them, because I'm just going to go from one to the next right in a row. All right, g of 4. That's the square root of x plus 2. So that means the square root of some x value plus 2. What's my x value? 4. Well, the square root of 4 is 2 plus 2. That answer is indeed 4. All right, last one. This is actually a little different because I've got to do the same process I did for A and for B, but I've got to do it twice. Okay? My function f, okay, that's 4x plus 7. Well, I'm putting a 5 in there. It's 20 plus 7, 27. All right? Plus, right, well, what's h of 2? Here's h. Okay, now you'll notice I have two variables that I want to plug in my number 2 in for. So I have x squared minus 3 times x. Woo. Okay, it was x squared minus 3x again. I'm putting parentheses in for my x value. That tells me where exactly I'm going to put my number 2. Okay, 2 squared is 4, minus 3 times 2 is 6. That's negative 2. 27 plus a negative 2. There you go, 25. All right, on to D, E, and F. All right, well, let's do this. G of 25, that's this equation right here. It's the square root of x, that's weird, plus 2. All right? My number that I'm putting there is 25, so 25. The square root of 25 is 5 plus 2. That gives me 7. This is 7. Minus h of negative 2. All right? Let's not forget h is x squared minus 3x. So it's x squared minus 3 times x. Again, I'm throwing a negative 2 in there. Negative 2. That's 4 plus 6. A negative 3 times a negative 2, let's not forget. Negative times negative is positive. That's 10. 7 minus 10, that's negative 3. Boom. There you go. All right. Now, we have a fraction. Big deal. What is f of negative 1? Using this, I'm putting a negative 1 in for my x. So it's 4 times negative 1 plus 7. It's negative 4 plus 7. That's 3. That's the top. All right? Well, now let's figure out what's g of 1. So I'm using this. Okay? It's the square root of my x value plus 2. For this case, my x is 1. The square root of 1 is 1. That's 3 as well. All right, 3 over 3, that equals 1. Good deal, nothing crazy. All right, now we're going to do the same thing. We're going to do it twice. Once for G, once for F. But now we're going to multiply these two things together. So, G of negative 4. That means we're going to use this, or excuse me, G of 4. And I'm going to throw a 4 in for my x. So it's the square root of x, right, plus 2. And my x this time is 4. Okay, that's 2 plus 2. That's 4. Don't forget, I'm multiplying times half of negative 2. Well, I'm going to take my half here and throw in a negative 2. So it's 4 times x plus 7. Well, my x is negative 2 here. So it's negative 8 plus 7. That's negative 1. 4 times negative 1 is negative 4. So it's more of the same. We're just doing it more than once. Okay? We're not inputting one number and that's it. We're inputting one number. We're inputting another number in a function, and then we're doing a math calculation with those two responses. For the first one, we subtracted them. For the second one, we divided them. And for the last one, we multiplied them. Pretty simple. So we move on to G, H, and I. These are slightly different, even more so. How come? Because these don't have numbers in them anymore. They're variables, okay? The last one has a variable and a number. Let's take a look at these things one at a time. All right? I'm going to take f of x. I'm going to add that to h of x. Well, let's take a look. F of x is 4x plus 7. That's what f of x equals. So here is 4x plus 7. I'm going to take that whole function and add that to h of x. This is what h of x equals. So I can substitute that whole function in here. Okay, h of x is x squared minus 3. All right? And all I'm going to do is I'm going to switch where it's combined like terms. I have x squared. Okay, I have 4x minus 3x. That's plus 1x. And then I have this 7 by itself. And I can't combine that with anything. And there you go. Simple. It's nothing crazy. All right. Well, let's do another one. We have f of x. Okay, this is 4x plus 7. And I need to multiply that by another f of x, which is 4x plus 7. This is f of x. Okay, that's what it equals. So we've got to multiply it times itself. You can set up a window. You can do like a lattice window, a tic-tac-toe board, and multiply and combine. Or you can FOIL, or double distribute, which is what I like to call it. 4x times 4x, that's 16x squared. Don't forget, when I multiply, I need to add exponents. That's why it's x squared. All right? Now my 4x times 7 is 28x. All right? So I distributed my 4x, and now I got to distribute my 7. That's why I call it a double distribute. 4x times 7 again, that's another 28x. And last, I have 7 times 7. That's just 49. The only two terms I can combine are these two right here. So I still have 16x squared. 28 and 28 is 56x. And then lastly, plus my 49. Done. the last one here. This isn't f of x, okay? This is f of x plus 1. There's a big difference between this and this, okay? I am still going to use my f of x function. That's 4x plus 7. And I'm still going to write it, so there's parentheses for my x. But this time, instead of throwing a 5 in there, or a negative 2 in there, I'm literally going to put whatever is in parentheses here goes in these parentheses, because that's what's substituting into my x. It happens to be x plus 1. Now it's just a matter of distributing and combining. 4 times x is 4x. 4 times 1, that's 4, plus 7. The only thing I can combine are these here. So it's 4x plus 11. And there you go. So let's talk about composition of functions. You guys are starting to get the hang of functions. F of x, f of 2, I put 2 in the function f of x, and so forth. Now we're going to talk about a composition of functions. All right? I don't know if you remember geometry or not. You might have seen something that looked like this. Like, I want to reflect across the y-axis, and I want to reflect across the line y equals x. There's this little symbol right in there. Okay? Now, the question is, can you remember what that little symbol means? What it really means is follows. So if I'm looking at this right here, okay, I need to go backwards. My reflection over the y-axis should follow my reflection over y equals x. So I need to do my reflection of y equals x first, because this reflection follows that. It's in order. All right? Now, you may or may not remember that, and that's fine. You don't have to remember reflecting for geometry to understand this concept. But you do need to understand what I'm about to tell you right now. The easiest way to remember this, in my opinion, you have f of g of x. That's how it's pronounced. F of g of x. Whatever is closest to the x, you do that first. I have my classes, put that in parentheses. I figure out what this is, and then that goes into f. So it can be rewritten like this. F of g of x. Okay, whatever value this is ultimately going to go into the f function. You may or may not get that completely. Maybe you kind of get it. Maybe some of you are, okay, hey, I got it. Let's do some examples and you can see what I'm saying. All right? So I have 1a. I'm taking f of g of negative 2. I'm immediately, whatever function g happens to be closest to my input, negative 2, I'm going to do g of negative 2 first. Once I do that, whatever value that is going to be put into f. All right? So let's do this. G of negative 2, and I look at my g function. That's this right here. Okay? It's the absolute value of whatever my x is minus 3. All right? Again, nothing new. My negative 2 goes into my x. That would be the absolute value of negative 5. And of course, absolute value takes anything negative and makes it positive. So that would be a positive 5. So now, just like the past few problems we didn't do our input the functions once, we were doing them twice, then we multiplied. We did them twice, then we divided them. We did 2 of them, and then we subtracted them. Same thing. If g of negative 2 is 5, that means this value here is 5. G of negative 2. That's like saying f of 5. So whatever value this is has to be 5. That's going into f. So now I need f of 5. So I take this, 2x minus 5, 2 times my x value minus 5. That is 10 minus 5, and that happens to be 5. A lot of 5s in that problem. It's a weird problem, but we did it right. Let's do the next one. Okay, this one, they give it to us in the rewritten form. They don't put a little of in there. They actually give it to us like how I would rewrite it. I need to figure out what f of 10 is. And that's what's going into the g function. All right, well, let's figure out f of 10. F of 10 would be taking this right here and putting a 10 in for x. So it's 2 times x minus 5. Well, that's a 10. That's 20 minus 5, which is 15. So f of 10 is actually 15. So now I'm going to take g of 15, and I'm done. You see how I'm saying we're doing it twice? All right, we're doing this process twice. G, right here. That's the absolute value of x minus 3. Okay, well, 15 is what's going in. That's the absolute value of 12, which is 12. There you go. Bada boom, bada bing. Done. If you want to try these two on your own, again, at any time in the notes, if you want to pause it and try a few of these or go ahead, then see how I do these and work these out, you're more than welcome. Okay, 2a. Right, the first thing I want to do is write this. So let's put it together. So it's f of g of negative 3. All right? G is a new equation. This is where it is very, very easy to make a mistake. This is why I use parentheses for all my variables. Let me show you. G of negative 3. I take g of negative 3. That's the negation of my x variable squared plus 1. Negative 3 is what's going in here. We are not squaring this negation. According to PEMDAS, I need to do my exponent first. That's the negation of negative 3 squared, which is 9 plus 1. Okay? Notice the parentheses only went in for my x. All right? Now that's negative 9 plus 1, which is negative 8. That's what g of negative 3 is. So I need to find f of negative 8. All right? Because g of negative 3 is negative 8. All right, well, here is my f function this time. So f of negative 8 would be, I take x and I cube it, and I add 3 times x squared. Cool, all right. So I take negative 8 and I cube it, and I take negative 8 and I square it. All right. Well, negative 8 cubed, that's negative 8 times negative 8 times negative 8. All right. Negative 8 times negative 8 times negative 8. And my answer is going to be negative. 64 is 8 times 8. And then times another 8. So 64 times 8 is 32, carrying a 3. Negative 512. Plus, okay, negative 8 squared is 64. So it's 3 times 64. 12, carry the 1. That's 1819. Plus 192. And if I do my math right, and I combine those, I get negative 320. There you go. All right, so you can see how it's a little bit of a step up just because you're working with bigger numbers, but you get a calculator in this course. There's no excuse you shouldn't get that. All right? F of negative 4. We need to find this first. Oh, awesome. So, f of negative 4. F of negative 4 means I take x and I cube it, and I add 3 times x squared. Again, I'm using that. Negative 4 cubed is minus 64, plus 3 times negative 4 squared. 16 times 3, I believe that's 48. And if I add those together, I get negative 16. Right? So this is actually negative 16. So I want g of negative 16. Not too bad. I'm going to use this right now. It's my g function. G of negative 16 is the negation of my x squared plus 1. If I square negative 16, that's 256. Now I need to negate it. Plus 1. That's negative 255. There you go. Example 3. Now it's a word problem. It's asking us the same thing. If f of x is 2x minus 1, and g of x is 3x plus 5, find f of g of x. Are there numbers in here? No. I need to take g of x. This is g of x. I need to find f of g of x, which is 3x plus 5. Okay? That's what g of x is. 3x plus 5. So that's what needs to go into my f function. So, f of 3x plus 5 goes into this. It's 2 times x minus 1. What goes in for my x? 3x plus 5. And all I'm going to do is distribute and combine. PEMDAS. Parentheses. I can't combine this. I got to leave it like that. No exponents. Next is multiplication or division. Distributing is multiplication. 6x plus 10. Don't forget, minus my 1. That's 6x plus 9. Now you know what you're doing. Next one. If f of x is x squared minus 5, and g of x is x plus 1, all right, find f of g of x. Remember, whatever's closest to our variable, we do first. So that's the same thing as saying g of f of x. So what is f of x? It's this right here. That's going to go in the f of x. So I really have g of x squared minus 5. All right? What's my g? And I'm going to rewrite this over here. I've got g of x squared minus 5. That goes into here. That goes in x plus 1. So what goes in this stuff? It's x squared minus 5. Okay? PEMDAS. Parentheses. I can't combine exponents. Well, I only have one exponent with my x. There's nothing I can do there. Multiplication and division. I don't see it. The only thing I can do is my addition and subtraction. I can combine two things. I have x squared. I have minus 5 plus 1. That's minus 4. There you go. All right. We are now going to use tables to figure out what our functions are. Okay? We're going to use tables. You'll notice this is f of x. All right? And this is g of x. Now, keep in mind, this row is my x values, and this is pretty much f of x, which is my y values. Same thing here. Here's my x. There's my y. All right? So anytime, and this is how I want you to look at this right here. Anytime I see like 5a, f, I know I'm using this table here. That's my f function. They're telling me When my x is 3, what's my y? Okay, so look at the table here. And be careful not to flip this around. When my x is 3, what's my y? 5. It's that simple. All right? Let's try the next one. You want to pause it for the next one on your own? Now it's time to do it. It's quite simple. G, I'm using this function right here for g of x. When my x is 6, what's my y? Oh, my x is 6. My y is 10. All right? So, let's do some of these bad boys. Let's share a little. All right, next one. Same deal, okay? I want to do f of 2 first. So that's like g of f of 2. Well, what is f of 2? Okay, when my x is 2 in my f function, my y is 4. So that's like saying g of 4. How come? Because f of 2 is 4. Well, when my x is 4 in my g function, it actually equals 6. Wow, that's a bad 6. There you go. D. All right. G of 4. When my x is 4, that's nice. My y is 6. So this here is like 6. It's like saying g of 6. And what's g of 6? 10. Very good, very good, very good. Nice. Now, f of g of 3. We're on letter E now. When x is 3, what's my y value for g? When x is 3, my y value is 4. So this is like 4. F of 4. Okay. When my x value is 4, 6. There you go. Simple. But Visca, what about this next one? Oh my God. So instead of doing it twice, you're just doing it 3 times. Don't freak out, people. Still easy. You're just doing the same easy thing 3 times instead of twice. First, I need to find out what f of 3 is. Whatever that is, I put into the function f again. Whatever that is, will finally go into g. All right? So f of 3, when x is 3, my y is 5. So this is like 5. So now, I'm doing f of 5. And that will ultimately go into g. Sorry, I should have this one down. There you go. So what is my output, or my y value, in my f function when x is 5? You know, x is 5, y is 7. So that's like 7. So now, what's g of 7? Well, when x is 7, my y is 12. What I tell you? It's easy. I just have to do it a 3rd time instead of 2. All right, we're going to practice this, but instead of having tables, we're going to have a graph for my f function. We're going to have mapping diagram for my g function and a regular equation for my h function. Okay, we'll do 9 through 16, and then we'll be done with the video. Okay, f of 1. Here's my f function, so I'm using the graph. When x is 1, what's my y? Okay, here's where x is 1. Here's the points when x is 1. That's a y of -2. Simple. Okay? So when they give me an x value, I need to find the coordinates. And the coordinate is right here when x is 1. Here's where x is 1. What's the y value? -2. There you go. H of -3. Here's my h. Oh boy. I'm going to input. So that's x squared plus 2. Where did I get that? Right from there. What value am I inputting? negative 3. 9 plus 2 is 11. Bam. All right. Number 11. We're using two different functions. First, I need to use my f function. They want to know when x is negative 2, what's my y? All right. Here's negative 1. Here's negative 2 on the x. Where's the coordinate? Right here. What's the y value to that? Negative 1 on the y. Plus, oh man, g is a gimme. Anytime they give you a mapping diagram, what's g of negative 2? All right, well, here's negative 2. The output is 1. 1. Negative 1 and positive 1? 0. It's 0. I love when they have us use the mapping diagram. It's so easy. Okay. Let's do some more. Another g. G of 0. When x is 0, my input, my y is 2. 2 minus. Now be careful, I'm subtracting this whole thing. H of negative 1. Ooh, that means I gotta use this. Alright? So I can say it's my x squared plus 2. Negative 1 squared, that is 1 plus 2, that's 3. So this value is 3. What happens if I have 2 and I subtract 3? I get negative 1. All right. 13. Here we go. H of 6. Got to use my H again. That's x squared plus 2. When throwing a 6 in, that's 36 plus 2. That's 38. That's what this is. But keep in mind, I've got to multiply that by whatever f of 1 is. Okay, let's go over to our f function. When f is 1, right there, where's the point? Right here. It has a y value of negative 2. And if I multiply those two together, I should get negative 76. This ain't bad. This ain't bad. All right? Almost done here. H f of negative 2. Remember, I'm going to do whatever's closest to my input first. F of negative 2. Okay, we've done this once already. When my x value is negative 2, what's my y value? Here's negative 1. Here's negative 2. Here's the coordinate. That happens when y is negative 1. Okay? This is negative 1. So they want h of negative 1. You see what I'm saying? I'm going here again. Didn't I do this right here? H of negative 1 ended up being 3, didn't it? Now let's do it again. We have x squared plus 2. I'm throwing a negative 1 in there. That's 1 plus 2, and that indeed still is 3. That'll never change. And these are the final two problems for the first video of lesson 2. All right? G of 5. Well, the input is 5. The output is 6. So that's like saying h of 6. And lo and behold, we're using our x squared plus 2. So it's x squared plus 2. And I'm inputting a 6 there. That's 36 plus 2. That's 38. Look how easy this is getting. Very easy, very easy, very easy. Huh. Wow, they have g of f of 1 plus h of negative 3. No big deal. 3 easy things to do. First, what's f of 1? Now, when x is 1, that's right here, my point has a y value of negative 2. So they want g of negative 2, because f of 1 equals negative 2. I love when they give us the g. when the input for G is -2, the output is 1. So this whole thing is 1 plus h of -3. Again, I'm using x squared plus 2. I'm inputting a -3. That's 9 plus 2. That's 11. 11. 1 plus 11? Oh boy. Start to challenge us. 1 plus 11 is 12. And there you have it.